Good morning, students. Myself, Engineer Vinod Mahajan, Assistant Professor at Khalsa College of Engineering and Technology, Amritsar. Today I am having a brief introduction about a topic that is welding. So let's start with the topic welding. Welding is a fabrication process that joins materials, usually metals or thermoplastics, by using high heat to melt the parts together and allowing them to cool, causing fusion. Welding is distinct from lower temperature techniques such as brazing and soldering, which do not melt the base metal, or you can say that the parent metal. Comparison of welding with other joining processes. As we know that there are different techniques to join different parts for various applications such as bolting and riveting. So here we are having a brief comparison of welding with other joining processes. Welding is a permanent joint, whereas riveting and bolting is a temporary joint. Welding joints are lighter in weight as compared to riveting and bolting. Welding joints have more tensile strength and rigid as compared to riveting and bolting. Welding produces 100% efficient joint, which is not possible by any other joining process. Now we are having some different methods of welding. Welding is a method of joining metals permanently. It is an ancient method about 1500 years old. The method used in ancient days was forge or blacksmith welding. One of the methods of classifying welded joints is the method used to effect the joint between metal pieces. Accordingly, the methods are fusion method without pressure or with pressure and non-fusion method. So now we are having some discussion about fusion and some other methods. We are having fusion welding without pressure. A method of welding in which similar and dissimilar metals are joined together by melting and fusion their joining edges with or without the addition of filler metal, but without the application of any kind of pressure, is known as fusion welding without pressure. The joint mate is permanent. The common heating sources are arc welding, gas welding, and chemical reaction based, that is thermit welding. This is the example of fusion welding process. Next is pressure welding. This is a method of welding in which similar metals are joined together by heating them to plastic or partially molten state and then joined by pressing or hammering without the use of filler metal. This is fusion method of joining with pressure. Heat source may be blacksmith forge or forge welding, or electric resistance, that is resistance welding or friction welding. This is an example of a pressure based welding process uh, based on heat. Another category is non-fusion welding. This is a method in which similar or dissimilar metals are joined together without melting the edges of the base metal by using a low melting point filler rod, but without the application of pressure. Here in this slide we can see different welding processes. On the left side we are having pressure welding with or without filler metal, and on the right hand side we are having non-pressure based welding methods with or without filler method. In the left side pressure based welding method, we are again having a category based, that is on the basis of heat produced. We are having blacksmith's fire for production of lap joint, butt joint, V welding, T welding. Another category under the heat production is electric current based. Electric current based may be of spot welding type, seam welding type, product projection welding, butt welding or percussion welding. It can be under the category of special method based, that is diffusion welding, ultrasonic welding, electron beam welding, explosive welding. There is another method that is chemical reaction based, that is thermite welding. On the right hand side we are having non-pressure welding based welding processes. We can classify it as gas welding and electric arc based. Under the category of gas welding we are having oxyacetylene, oxyhydrogen and oxybenzene. And in the category of electric arc, again we are having two divisions, that is shielded arc and unshielded arc. Under the category of shielded arc, again we are having a classification, that is gas shielded arc and flux shielded. Under the gas shielded arc basis, we are having atomic hydrogen arc welding, argon welding, tungsten inert gas arc welding, metal inert arc welding, plasma arc welding. And in the category of flux shielded, we are having electroslag and electro gas based. Under the category of unshielded arc basis, we are having metal arc, carbon arc and tungsten. So this is the classification of welding processes. Now moving towards the advantages of welding, as we know that while we adopt some method for the joining, there are some advantages and disadvantages. So firstly we will go towards the advantages of the welding joint. So first is welding establishes strong, durable and permanent joint links. It is a simple process that results in a great finish. The technique, when used with filler material, produces a stronger weld than the base material. It can be performed at any place. It is an economical and affordable process. It is used in various sectors like construction, automobile and many more industries. Welding can be employed for limiting to very large production. Welding can be used for production, repair and maintenance. Now we are having some advantages of welding technology as well. So first is, it is hazardous when performed under the safety and security guidelines. It is difficult task to dismantle the joint material through welding. It requires skilled labor and electric supply. There can be physical and chemical changes in the structure of a parent metal. Edge preparation is generally needed for the welding. So here these were the some common disadvantages of using welding as a joining. Now moving towards the industrial applications, we are having some industrial applications such as machine building, transport building, power industry, space industry, defense equipment, process industry, construction industry and as also repair and maintenance. Now we will discuss all these in some elaborative form. First is, that is machine building. The technology is very widely used in machine and machining operation. All industry machines, machine tools, farm equipment, mining oil machinery, construction machinery, etc. are manufactured by the wide use of welding technology. Second is transport industry. Welding is used for the manufacture of railway engines and wagons, joining of rails, automobiles, ships, submarines, aircrafts and helicopters, etc. Third category is power industry. Boilers, turbines, generators, transformers, nuclear reactors, thermal, hydro, nuclear and other power plants are fabricated by extensive use of welding. Fourth category is space industry. Rockets, missile, spacecrafts use welding technology for fabrication. Another category is defense equipment. All tanks, gun carriers and other defense equipment use welding for fabrication. Sixth category is process industry. Roofs, columns, structures, piping vessels and tanks, machines, cranes, lifting devices for various chemicals, oil refineries, fertilizer plants, drugs and pharmaceutical, food and sugar, pulp and paper, and other process industries use welding technology very extensively. Seventh category is construction industry. Earth moving machines, road rollers, roofs, columns, trusses, bridges and towers are fabricated by welding. Last category is repair and maintenance. In addition to manufacturing and fabrication, welding is very extensively useful for repair, conditioning of worn out parts, surface coatings and other maintenance work. Uh, now we'll be moving towards another conditions. We will be having some welding positions. The common positions for welding processes are as follows: flat position, horizontal position, vertical position and overhead position. We can classify welding position initially in the four categories as we have discussed. Now we will discuss all these one by one. First is flat position. The workpieces are placed or held so that the axis of weld during welding remains in horizontal position. It is the easiest position for the welding process as the weld material is deposited on the upper faces of workpiece in a horizontal plane. As we can easily see in this diagram, two workpieces are held together in the horizontal position and we are having a flat position weld joint. Second category is horizontal position. We can use this horizontal position in two categories as we can say that grooved weld and fillet weld. Both grooved welded and fillet welding can be done in a horizontal position. First is grooved weld. The two workpieces where the two workpieces rest one over the other with their faces in the vertical plane. We can see easily in this the first diagram of groove weld, two workpieces are held together in vertical position and there is a joint, a horizontal joint, or we can say that the horizontal axis of the welded joint. Second category is fillet weld. The two workpieces are held at right angles to each other. The welding is done on the upper face of the horizontal piece and the vertical face of the vertical piece. The axis of the weld remains in horizontal plane. Again, in the second diagram, as shown in the fillet weld, two workpieces are held together in the mutually vertical position. Here we can see there is a welded joint shown in the diagram, which is at the upper side or the upper surface of the horizontal workpiece, and at the similarly at the point, or we can say that at the front face or at the vertical face of the vertical workpiece. Third position is vertical position. The axis of weld is either held vertical or slightly inclined. The welding usually starts at bottom and proceeds upward. Now we can easily also see there are two workpieces which are held together vertically, or we can say that they are mutually at their right angle, and there is a joint in between them, that is in the vertical position, or we can say that the axis of the joint is vertical. Last category is overhead position. The welding is done on the upper side of the workpiece, which is over the head of the welder. The edges and face of the weld is kept approximately horizontal. It is the most difficult welding position and requires very high degree of skill of the welder. In order to control the chances of the falling down of molten metal, the temperature of molten pool is kept low as possible. However, the surface tension of molten metal helps to keep it in its position. We can also see in this diagram there are two workpieces which are held together, and there is a joint that, or we can say there is an inverted V-type butt joint. Why this is inverted V-type butt joint? Because it is located above head. Okay, or we can say that it is overhead position of the welded joint. So moving towards another concept, that is welding techniques. There are two types of welding techniques used. First is leftward or forehand technique. Second is right hand or backhand technique. In both the welding techniques, proper cleaning and proper edge preparation of workpiece must be carried out for strong welds. So firstly we are having leftward welding. The tip of the torch is held at 60° to 70° to the plane, and the filler rod is inclined at 30° to 40° in the opposite direction. The plate edges are heated immediately after deposition of molten metal. The torch is held in the right hand and the filler rod is in the left hand. The flame can be given a circular rotation or moved from side to side for ensuring uniform fusion throughout. The torch tip and the filler rod are moved slowly in the directions towards left. This technique is efficient for welding materials up to 6 millimeter thickness. As we can see in this diagram, two workpieces are held together and there is a V type of butt joint. Okay, so we can see that there is a welding torch which is having an inclination of 60° to 70°, and there is a filler rod which is having again an inclination of 30° to 40° to the plane of the weld. We can also see that the welding torch is positioned at the right hand side and the filler rod at the left hand side, or we can say the welding torch should be in the hand of the right hand of the welder and filler rod is in the left hand of the welder. We can also see the direction of the welding joint as the arrow is indicating the movement towards left. Okay, that is why we can say that we are having this type under the category of leftward welding technique. Another method is, or another technique is rightward welding. The torch is kept at 40 to 50° in the right hand. The filler rod is kept at 30° to 40° in the left hand. Torch is moved towards right followed by filler rod. The cone of flame is deeper and this technique is used for heavy sections only. As again we can also see in this diagram which is showing the working process of rightward welding. Here we can easily see that there is a welding torch at the right hand and filler rod at the left hand. The welding torch is having an inclination of 40° to 50° with the plane of the weld, and filler rod is having an inclination of 30° to 40° with the plane of the weld. The direction of welding is moving from left to right. Okay, that is why we can say that it is a rightward welding technique. Now, after the completion of any topic, we are having some multiple choice based question answers. So again, I am having some questions for you students. You can solve these questions and give your answers to me, so that I can identify that which student is having the or which student is going through the concept, okay, properly. So first question is, which of the following is an example of plastic welding? We are having four options for this: gas welding, arc welding, forge welding and thermit welding. Again, I am repeating the question one more time. Which of the following is an example of plastic welding? Options are gas welding, arc welding, forge welding and thermit welding. You have to opt out any one answer, suitable answer. Second question is, which of the following is an example of fusion welding? The options are arc welding, forge welding, resistance welding and thermit welding with pressure. Again, I am repeating this question one more time. Which of the following is an example of fusion welding? Options are arc welding, forge welding, resistance welding and the last option is thermit welding with pressure. Next, third question is, in which of the following processes heat is created by blacksmith fire? And the options are forge welding, spot welding, projection welding and seam welding. Again, for your help, I am repeating this question one more time. In which of the following process heat is carried by blacksmith fire? Options are forge welding, spot welding, projection welding and seam welding. Moving towards the fourth question of this topic, that is, out of the following, which is non-destructive testing method of welds? The options are tension test, bend test, ultrasonic test and D is creep. I am repeating this question again one more time. Out of the following, which is non-destructive testing method of welds? Options are tension test, bend test, ultrasonic and last D is creep. You have to provide suitable answer, one suitable answer out of these four options. The last question is, in forehead welding, you have to fill this blank. In forehand welding, options are the torch points in the direction opposite to that in which welding is being done. B option is welding is done by right hand. C option is the torch points in the same direction in which welding is being done. D option is none of the above. You have to give one suitable answer for this blank. I am repeating this blank one more time of this fifth question, last question, one more time. In forehand welding, the options are A, the torch points in the direction opposite to that in which welding is being done. B is welding is done by right hand. C is the torch points in the same direction in which welding is being done. And last D option is none of the above. Okay students, thanks for today.